Alright, so the first conceptual question is why does the pressure calculation for an L pipe, or a pipe that turns, does not use the absolute pressure in the force balances? So this is essentially because the entire surface has atmospheric pressure acting on it, and the fluid has the absolute pressure, which is gauge pressure plus P atmosphere. And since the pipe is open on one end and closed on the other, the pressures cancel out in the force balance. Because they're going in opposite directions. And so this lets the atmospheric pressure cancel out, which is shown here. Second calculation question, you're flying with a water jetpack with an input tube length of 20 meters and a diameter of 20 centimeters. An intake volumetric flow of 0.05 meters cubed per second and two nozzles with an exit diameter of 3 centimeters. And the total mass of the system is 100 kilograms. So a lot of information. We asked, what is the maximum height that can be reached? And so this will essentially devolve into finding the force balance and then basically doing a physics 1 problem on acceleration, velocity, and distance over time. And so we're given the volumetric flow rate, the input diameter, the exit diameters, the mass of the system, and the maximum height to which it can accelerate. We're asked to find the maximum height. We have to assume viscous force is 0 because we're given nothing for that, and the xy force is 0 because the momentum in and the momentum out are both only in the z direction. We have to assume P absolute is P ATM because we're given nothing about pressure, and beta equals 1. And then we have density of water and gravitational acceleration. So we can start out with a force balance, force in minus force out plus force other, which in this case is force gravity, is the sum of the forces. Then we can get m in, velocity in, to get force in, and same process for force out where you have velocity out, m out, except I divided it by 2 and then multiply it by 2 back in the force calculation to find the velocity out for one nozzle and m out for one nozzle. And then I multiply essentially the force of the nozzle times 2. Force gravity times mg, and then sum all the forces, divide by the mass to get the acceleration. And here's where it becomes kind of a physics problem where use essentially this equation where x equals vt plus a over 2 times t squared, and use that equation over and over again until we get the velocity at 20 meters, which would be the maximum velocity. Then we have to find the time it takes to get to the max height, and then from that we can get the max height.